Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Fahrul Pralianta Bani Muhammad from Informatics Department, Politeknik Negeri Indramayu. In this opportunity, I would like to present our research entitled The Impact of Random Oversampling and Linear Discriminant Analysis on Software Defect Prediction using a deep neural network. So this is our outlines in our presentation that consists of 5 sections. There are an introduction, related works, proposed method, experimental result, and conclusion. Okay, section 1 is introduction. The appearance of software defects can be prevented through comprehensive testing. However, comprehensive testing cannot be carried out due to limited testing time and cost. Therefore, testing needs to be done only on software modules that are prone to errors, so that the testing effort can be as effective as possible. To determine the error-prone modules, an early prediction model of software defect is needed. But there are several problems to predict the software defects. The first is an imbalanced class distribution between defects and non-defect classes in the dataset. Secondly, the dataset also has high dimensionality features. Both of these can lead the prediction model to poor classification results. So the related works are: research on predicting software defects has been conducted by several previous researchers, including the class balancing method, feature selection method, classification method, and ensemble method for optimizing the prediction result. So the related works to be discussed in this research are random oversampling, linear discriminant analysis, and deep neural network. Random oversampling. This method makes it possible to create new data based on a class with a smaller number by randomly selecting training data from the class and then duplicating it. The process of selecting and adding data is repeated until the number of data for the minority class equals to the number of the majority class. So you can see the ROS algorithm flowchart right here. Linear discriminant analysis. So this algorithm is able to map high dimensional data to low dimensional data to be used as training model input. The goal of the LDA algorithm is to maximize the between labels distance and minimize the within label distance on reduced dimensions. The LDA algorithm can be implemented to extract one or more independent new features that separate most of the classes from a dataset, which are defects label and non-defects label. So the next is DNN, or deep neural network. The neural network structure can consist of an input layer, an output layer, and a hidden layer. A deep neural network is a network consisting of many hidden layers. The deep learning process is about finding the connection weights between each layer in the network. So this is the illustration of a simple neural network. This consists of input layer, hidden layer, and output layer. The deep neural network has more hidden layer. So this is the previous research. In the previous research, there are two ensemble models that have been conducted, including class balancing, feature selection, on software defect prediction. So the first is a combination of ROS class balancing and random forest classification using the CM1 dataset in 2018. It produced an accuracy of 82.6%, probability detection of 10.6%, and AUC of 51.9%. Secondly, a combination of LDA feature selection and decision tree classification that using the same dataset in 2020. Okay, based on the result, it produced an accuracy of 75%, AUC of 76%, and admixture of 76%. So we can see the first combination has the highest accuracy, but it can't predict a software defect well based on its probability detection or recall value. It only 10.6%. So this is our proposed method. We can see that our input is CM1 dataset, and the next is pre-processing stage, which consists of remove duplicates and normalization. So after the pre-processing stage is complete, then the balancing class is carried out using the ROS method. ROS can make the number of minority class equal to the majority class. After the class balancing stage is complete, the next two scenarios are carried out. Namely, classification stage and feature selection stage. So here we want to find out the difference between the balancing class with and without feature selection in DNN method. Tenfold cross-validation used in this research for finding out the performance measure. There are 10 parameters output for comparison purposes, i.e., AUC, balance, accuracy, specificity, PG or probability detection, PF or probability of false alarm, error rate, precision, F-measure, and G-means. Okay, this is our experimental result. So this is the result of pre-processing stage. You can see the information in detail about CM1 dataset after duplicates data removal and after the normalization. CM1 dataset consists of 327 modules, 37 features, which consists of 42 defective and 285 non-defective. CM1 is a NASA spacecraft instrument, which built in C or C++ language program. So after the normalization, the data will look like this. All data are converted to decimal number from 0 to 1. Okay, the next step is class balancing. ROS is then carried out by increasing the minority class population, i.e. defective class. A total of 248 new data labeled defective class was generated from this stage. You can see now our module is increasing, and the defective and non-defective classes now balance. Next, the feature selection. LDA method maximizing the distance between labels and minimize the distance between labels on reduced dimensions. It is shown that true label or 1, you can see here, it consists of data with range 0 until positive 1. Sorry, I mean here. In label 1, LDA feature 0 and positive 1. Okay. Otherwise, the false label or 0 is consists of data with range minus 0 until down to minus 2. You can see it here from 0, minus 1, and 2. Oh, I mean, I'm sorry, it's plus 2 +2 and -1. Okay. The cross validation. This is what is it? The result of cross validation. We use tenfold cross validation, and this is the what is it? Testing and training data, which consists of several defective and several non-defective on the testing, as well as the training. Every fault is consists of 570. So this is our performance measurement. Based on the table 5, the best ensemble model is a combination of ROS, LDA, and DNN. Since the performance measure of a defect prediction model can be represented by 5 parameters: AUC, PG, PF, balance, and G-means. You can see it in table 5. So this is the comparison of AUC values between them. ROS, LDA, DNN win this comparison. About probability detection or recall, ROS, LDA, DNN outcome the rest of them. In probability false alarm, there is no output of PF on the other method. On PF, the lower, the better. Balance, we can see that ROS, LDA, DNN has the best balance feature. Balance value. NG means also ROS, LDA, DNN outcomes the other method. So this is our conclusion. Based on our experiment, it can be concluded that our proposed method, ROS, LDA, DNN, can outperform ROS, DNN, ROS random forest, and LDA decision tree. There is a significant increase in the result except for the accuracy. However, the highest accuracy gain, ROS and random forest, has the worst probability detection or recall among of all. The next future work can be experimented by other ensemble models using the combination of several class balancing and feature selection methods for getting the best result. Okay, thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.